Hello guys, is audio video clear? Is audio video clear? So absolutely correct. Audio video is absolutely clear. So we'll start our class. We'll start our class. Okay, we'll start our class. Quickly join the classes. Quickly, everyone join the class. Okay, wait a second. We'll start our class quickly. Everyone. Okay, so welcome everyone to the resultant. So for today's class, we'll discuss the very important concept. We'll discuss very important concept related to the yeah, related to the shear force diagram and bending moment diagram. Okay, okay. So this is all about me. This is all about me. You can go through my the profile. Okay. So this is all about me. My name is Engineer Mohammed Shoaib, and I have the 2+ years of experience in teaching. Okay. So what is going on in our app? So I request everyone, please join my Telegram group. Okay, for the class links, PDFs. Okay. So we have a aim batch for RRBG CBT2, okay, going on in our app. So you will get PYQs, quiz discussions, you will get test series regarding there, you will get doubt solving sessions, okay. So for that case, you need to contact the numbers given in, okay, okay. And also, what are the features of our app? Okay, so you will get class handouts, okay, you will get every class handout, you will get class pools, okay, you will get class pools, you will get daily practice, you will get daily practice problems, educator support, you have live classes for you, study material for you, unlimited courses for you, okay. So top educators on platform like Abhinav sir, Richa ma'am, okay. So let's start our class. Let us start, and we have the CBT1 books are available for RRBG aspirants, okay, on our app. You can contact, okay. So let us start our concept. Let us start our concept. That is the shear force and bending moment diagram. What is the shear force and bending moment diagram? So first, I will discuss what are the supports. Okay, I will discuss what are the supports. These supports are provided, okay, under the beam. So which type of supports we have? We have the first the roller support. Sir, what is roller support? We have the hinge support. We have the fixed support. It is fixed here. Fixed support, and we have the guided roller support. And what are the reactions available for these types of supports? Okay, so this will be discussed in the section. This will be discussed in the section. So the roller support looks okay. If we have the beam here, if we have a beam here, let us suppose this is our beam. Okay, the roller support will looks like this. This is the roller support. This is the roller support. Okay, this is the roller support. So what are the reactions available on the roller support. Okay, what are the reactions available on this roller support? So, sir, this roller support, here vertical reaction is available. Vertical reaction is available. Okay, vertical reaction is available. That means vertical reaction is available. Sir, the horizontal reaction is zero here. Sir, the horizontal reaction is zero here. Horizontal reaction is zero here. Absolutely correct. And the moment around this roller support is taken as zero. Okay, there is no moment development. There is no moment development. That is, here only the vertical reaction develops. Okay, on the roller support, you will get what? Sir, we will get only one type of reaction. Okay, we'll get only one type of reaction. Absolutely correct, sir. We'll get only one type of reaction. Next, okay, what is the next support? Sir, that is the hinge support. Okay, how this hinge support looks like, I'll show you. I'll show you, don't worry. So this hinge support, let's suppose this are beam, this are beam. Okay, this is the hinge support, this is the hinge support. Okay, so what are the reactions available? What are the reactions developed under this hinge support? Okay, what are the reactions developed under this hinge support? So you get vertical reaction, you get vertical reaction at this point. So you get vertical reaction at this point, absolutely correct. Okay, and you get what? You get horizontal reactions on this support. You get horizontal reaction on this support. Absolutely correct, sir. We get horizontal support, horizontal reactions. Okay, this beam cannot move in the vertical or horizontal direction. Absolutely correct. So the movement around this support, the movement around this support is taken as zero. The movement around this support is taken as zero. Okay, on this support we have the three unknowns. Okay, we have the three unknowns. Okay, we have the three unknowns. If we talk of this roller support, sir, there is only one unknown. There is only one unknown. That is the vertical reaction. Okay, unknown is here one. Unknown is here one. Absolutely correct, sir. Unknown is here one. Okay. If you are talking about the hinge support, on the hinge support, we have the unknowns as two. Okay. We have the unknowns as two. Here are the two unknowns. That is the vertical reaction and the horizontal reaction. And the bending moment is zero. And the bending moment is zero. Absolutely correct, sir. Absolutely correct, sir. Now we have the fixed support. So what is fixed support? Okay, what is fixed support? This is a fixed type of support. The beam is fixed in the support. Okay, the beam is fixed in the support. There is a development of vertical reaction, horizontal reaction. There is a development of what? Sir, there is a development of vertical reaction. There is a development of vertical reaction. There is a development of horizontal reaction. There is a development of movement also. There is a development of movement also on this support. That means vertical reaction here is okay, not zero. Vertical reaction is not zero. The horizontal reaction is also not zero. Okay, and here the moment is also not taken as zero. Rather, there has the values. Okay, that means we have the three unknowns. So we have the three unknowns available. Okay, three unknowns available. We have the three unknowns available for the fixed support. Absolutely correct, sir. We have the three unknowns available for the fixed support. Okay. Okay. Now, what is the guided roller? What is the guided roller? So another type of roller. Okay, another type of support, guided roller. How this guided roller looks like? Let's suppose this are beam. Absolutely correct, sir. This is beam. Okay. So we are providing the guided roller support. Okay. We are providing guided roller support. So this is the guided roller support. This is the guided roller support. Okay. Sir, this is guided roller support. Okay. So what is the reactions here? What are the reactions here? What are the reactions here? Okay. So there is a development of vertical reaction. There is a development of vertical reaction. Sir, there is a development of moment also. Okay, there is a development of the moment also, moment M. And the horizontal reaction here is zero, sir. The horizontal reaction is here zero. So I'll write down horizontal reaction. Horizontal reaction H is zero. Okay, horizontal reaction is zero. That means we have the two unknowns. One is the vertical, another one is the moment. Okay, and the horizontal reaction is zero. This guided roller may have the different orientation also. Okay, it can be put in the horizontal or vertical direction also. Let us suppose this our beam. Okay, this is our beam. Absolutely correct. Sir, this may be the orientation of the, this may be the orientation of the what? This may be the orientation of guided roller support. Now here, sir, here vertical reaction is zero. There is no vertical reaction. Sir, vertical reaction here is 0. Okay, but sir, the horizontal reaction is not 0. Horizontal reaction is not 0 here. Sir, horizontal reaction have some value, okay? And the moment is also there. And the moment is also there. Absolutely correct, sir. There are the two unknowns also. Here are the two unknowns also. But the unknowns are different, sir. But the unknowns are different. Absolutely correct. Okay. So we have the types of support. First one is the roller support. Second one is the hinge support. Third one is the fixed support. And the last one is the guided roller. So in case of the roller support, we have the horizontal reaction taken as 0. We have the vertical reaction taken as okay. Vertical reaction have some values. And the movement is 0. Absolutely correct. And for the hinge support, okay, anyone in the class, for the hinge support, sir, we are taking vertical reaction, we are taking horizontal reaction, and the movement is 0. That means there are two unknowns. There are two unknowns. Absolutely correct. Then for the fixed case, there is the horizontal reaction, there is the vertical reaction, there is the movement also. Okay, absolutely correct, sir. So what is guided roller? It is another support. Here the movement is not 0. Rather, vertical reaction or horizontal reaction can be 0. Either of the two can be 0, depending upon the orientation. So when it is placed in the horizontal position, the horizontal reaction is 0. And when it is taken in the vertical direction, the vertical reaction is 0. Absolutely correct, sir. Vertical reaction is 0. At the end, we are getting the two supports. We are getting the two unknowns here. Okay. So we are getting the two unknowns here. Okay. Shall we proceed? Shall we proceed? These are the types of supports under the beams. Okay. These are the types of supports under the beams. Absolutely correct, sir. Next part of our lecture is the type of beam. Is the type of beam. Sir, first is the simply supported beam. First one is the simply supported beam, and the second one is the continuous beam. We have the cantilever beam. We have the beam with the internal hinge. We have the fixed beams. Okay, these are the basic pointers. So, what is simply supported beam? Okay, what is simply supported beam? The simply supported beam. We have this beam is placed on the hinges. This beam is placed under the hinges. Okay, absolutely correct. So on the one side, we may have the hinge support. Okay, we may have the hinge support, and on the other side, we are taking sir roller support. Absolutely correct. We are taking sir roller support. Roller support. Absolutely correct, sir. Roller support is there. Okay, okay, roller support is there. Okay, sir, when the span is less than 350, when the beam span is less than 350, we are using this simply supported beam. Okay, so I'll write down for small. This is used for small spans. For small spans. Absolutely correct, sir. For small spans. Okay, less than 350 feet. Less than 350 feet. Okay. Sir, why we are putting here the roller support? Why we are putting the roller support? Okay, sir, if we are using the two supports like hinge supports, not the roller support, what will happen? Sir, what will happen? Remember the concept here, sir. What will happen? What will happen if we are putting the roller supports? Sorry, we are putting hinge supports. What will happen? Sir, if we increase the temperature of the structure, sir, there may be the increase in the temperature of the structure. Sir, there is no movement either in the horizontal direction or in the vertical direction. So remember here in the first case, there is the okay, there is the movement, there is the horizontal movement. But in the second case, sir, there is a development of vertical reaction, there is a development of horizontal reaction. There is also the development of vertical reaction, development of horizontal reaction. So that means there is no okay this structure cannot expand, so there are temperature stresses, so we are not allowing this hinge support also. Okay, okay. Now, sir, why if we are putting the two roller supports on both the sides, what will happen? What will happen, sir? What will happen? So we are using the roller supports on two sides. What will happen, sir? This is a roller support, there is a roller support. Sir, what will happen? Sir, there may be the inclined loading case. There may be inclined loading case. Absolutely correct, sir. Inclined loading case. Sir, what will happen to this inclined loading case? Sir, for this loading case, there will be horizontal reaction, there will be vertical reaction. There may be horizontal reaction, there may be vertical reaction. Absolutely, sir. Sir, then what will happen? What will happen, sir? If we have the horizontal reaction here, Sir, no horizontal reaction. Horizontal reaction is zero. Horizontal reaction is zero. Sir, horizontal reaction is zero. No. That means this structure will move. Sir, this structure will move in the horizontal direction. So it is necessary to put one support as the hinge and other as the roller. Okay? Other as the roller. Now, when we put the hinge support, there is a development of horizontal reaction and the structure will not move. Okay? Absolutely correct. Sir, this is the simply supported beam. This is the simply supported beam. Now we have the continuous beam. Sir, what is this continuous beam? Okay. Sir, this continuous beam is used for the large spans. Okay. The first point of reference, large spans. It is used for large spans. Absolutely correct, sir. Used for large spans. Okay. Used for the large spans. So what is continuous beam? There may be, okay, more than two supports. Remember, it is more than two supports. Okay. Sir, there may be more than two supports. There is more than two supports. I'll write down more than two supports. More than two supports. Okay, two supports. There is more than two supports. Absolutely correct. Na? Okay, are you getting my point? Okay, in the chat section, come on everyone. Okay, large span. Okay, more than supports, more than two supports. Sorry, more than two supports. Okay, absolutely correct. More than two supports. Okay, so we have this beam like this. We have this beam like this. Sir, there are more than two supports. There are more than two supports. These supports may be, okay, these may be roller, these may be hinged. Okay, so there is a hinged support. There is a hinged support. Okay, there is a roller support. There is a roller support, and there is again the roller support. Okay, so this is all about what? This is all about the continuous beam. This is all about the continuous beam. Okay, sir, for the continuous beam, we have the more than two spans. Okay, we have more than two spans. Sir, this is one span. This is one span. This is another span. So more, okay, we have more than two spans. More than two spans. More two spans. Absolutely correct, sir. And there are more than two supporters. Supports are more than two. Okay, minimum is three. More than two supports. Absolutely correct, sir. This is your continuous beam. Okay, we have another case of cantilever beam. So what is cantilever beam? Very, very important. What is cantilever beam? What is cantilever beam? Okay, so I'm making the figure here for the continuous beam. Okay, so the continuous beam is free from one side. The continuous beam is free from one side. Absolutely correct. But sir, it is fixed from the other side. There is the fixed support. Remember, hinged fixed support. There is a fixed support. Okay, there is a fixed support. So it is fixed here. It is fixed here. Fixed support. Absolutely correct, sir. This is fixed support. Okay, this is free. Okay, I'll write down one end is free. One end is free. One end is free. Okay, and the and another end another end is what? Sir, another end is fixed. Another end is fixed. Okay, absolutely correct. Another end is fixed. Okay, so what are the unknowns? We have the three unknowns here. We have the three unknowns. We have the three unknowns here. Okay, okay, sir. We have the unknown of vertical reaction. Vertical reaction. We have the unknown of horizontal reaction HA, and we have the unknown of moment. We have the unknown of the moment. Absolutely correct, sir. Okay, this is the cantilever beam. Now we have the beam with the internal hinge. Okay, beam with the internal hinge. This internal hinge is provided, okay, internally in the structure. So how this beam looks like, I'll make this beam. Okay, we have the beam here. We have the beam here. Absolutely correct, sir. We have the beam. Okay, this is one part of the beam. This is one part of the beam. Sir, there is what? There is another part of the beam. Okay, we are developing internal hinge. We are developing internal hinge on this structure. Okay, internal hinge on this structure. So this is the internal hinge. Okay, there are the supporters. This is the simply support. This is what roller support. This is here again roller support. This is again here roller support. So this is the beam with the internal hinge. Here hinge is provided. Okay, sir, hinge is provided. Hinge is provided internally. Okay, hinge is provided internally. Hinge is provided internally. Absolutely correct. Okay, hinge is provided internally. So this is what? This is the beam with the internal hinge. Okay, okay, cantilever beam. Is everything clear? Shall we proceed? Is everything clear? Is everything clear? Shall we proceed for the next? For the next, okay. What is the next? Fixed beam. What is fixed beam? It is not find, it is fixed beam. What is fixed beam? Anyone, what is fixed beam? But this fixed beam is nothing. It has the fixed supports on two sides. Okay. It has the fixed supports on two sides. So I'll make the beam here. I'll make the beam here. So this is fixed beam. That is fixed in both the sides. It is fixed in both the sides. Okay. So what are the number of unknowns? What are the number of unknowns? What are the number of unknowns? Sir, there is what? There are six number of unknowns. What are the number of unknowns in case of fixed beam? There are the six number of unknowns. Okay. So I'll write down. I'll write down. This is the fixed support. This is fixed support. This is hinged. This is fixed support. This is fixed support. Absolutely correct. Okay. Sir, unknowns are here. Unknowns. What are the number of unknowns? The unknown will be, okay, if this is A end and this is B end of the beam. So there is vertical reaction at A. There is horizontal reaction at A. There is moment at A. Okay. Again, at the end B. So there is vertical reaction at B. There is horizontal reaction at B. And there is moment at B. These are the unknowns. That is six unknowns. Absolutely correct. There are six unknowns. Okay. There are six unknowns. Okay. Anyone in the chat section? Come on, everyone. Okay, write down this fixed beam. Okay. So shall we discuss overhang beam? What is overhang beam, sir? What is overhang beam? Okay. As the name suggested, overhang beam. Some portion of the beam will be on the what? On the overhang. Okay, on the overhang. So I'll write down this overhang beam. This may be single overhang. This may be double overhang. Okay. There may be single overhang. There may be double overhang. Okay. So first, I'll make the single overhang. So this is the beam. This is the beam. Okay, this is the beam. This is the beam. Okay. On the one side, we have what? On the one side, we have the hinge support. Okay. And at some distance from this hinge, we have another support. We have another support. That is the roller support. Sir, this part is overhang. Only one side is overhang. That is only single overhang. Okay. Only one part is overhang. This is single overhang beam. Okay, this is single overhang beam. Wait a second. This is single overhang beam. This is single overhang beam. Single overhang beam. Absolutely correct, sir. No confusion. No confusion. No confusion. Sir, what is double overhang beam? What is double overhang beam? So we have another beam here. Okay, it is overhang. Okay, from both the sides now. From both the sides. Absolutely correct. This is overhang from both the sides. So this is overhang from both the sides. There is a hinge support. There is a hinge support and there is a roller support. Okay. Okay. So this part is overhang. This part is overhang. So this is what? This is double overhang. This is double overhang. Okay. This is double overhang. This is double overhang beam. Double overhang beam. Okay. Okay, guys. Everyone in the chat section, this is double overhang beam. Is everything clear here? Okay, what are the types of beams? We have different types of beams. We have the simply supported beam. We have the cantilever beam. We have the what? We have the continuous beam. We have the beam with the internal hinge. We have fixed beam. We have the overhang beam. And all the beams are discussed here. Okay? All the beams are discussed here. All the beams are discussed here. Anyone in the chat section? Okay, shall we proceed? Shall we proceed for the next section? Analysis of beams. How this analysis of beams is done? How this analysis of beams is done? Anyone? Okay. What are the analysis? What are the analysis in the beams? Very, very important topic. Okay. From this section, almost you will get two questions in every AEJ exam. Okay. In every AEJ exam. So I'll be discussing the overhang beam. Okay. Sorry, I'll be discussing the analysis of beams. Okay, analysis of beams. So what is analysis of beams? So analysis of beams include the finding out the reactions, finding out the moment, finding out the vertical reaction, finding out the horizontal reaction. That we have discussed lastly. Okay, that we have discussed lastly. So in case of the analysis of the beams, we are considering a stable structure. Okay, a structure is stable. I write down for stable structure. For stable structure, for stable structure, for stable structure. Okay, for stable structure. Summation of forces in vertical direction must be equal to zero. Very, very important. So the summation of forces in the vertical direction, okay, must be taken as, or in the vertical direction must be taken as zero. Absolutely correct. Okay, must be taken as the zero. Now, another case, and summation of forces in the in the vertical reaction, in the horizontal reaction, okay, in the horizontal reaction must be taken as zero, must be taken as zero. Okay, okay. So I'll take these sections. So let us suppose this is our y direction, this are x direction. Okay, this are x direction. Okay, and this is the movement z direction. This is the z direction. Absolutely correct. Okay. So I am writing here moments, oh, sorry, forces, okay, in the x direction must be zero, must be zero. Summation of forces in the x direction must be zero. And the summation of forces in the world in the y direction must be zero. And the moment around z must be zero for the planar structure must be zero. Okay. And the forces in the z direction must be zero. Okay, absolutely correct. So the forces in the x direction must be zero. Forces in the y direction must be zero. Very, very important concept. Very, very important concept. Okay, very, very important concept. Okay, so the moment summation moments must be also equal to zero in the z direction. Absolutely correct. Okay, okay, absolutely correct. Sir, what if we are putting the internal hinge in the structure? If we are putting the internal hinge in the structure, what will happen? What will happen? This internal structure will provide us the, okay, will provide us the additional equation for the analysis of the, for the analysis of the, okay, for the analysis of the structure. Now, okay, let me first, okay, this analysis of beam, sir, what, how many number of equations you need to solve the structure? Okay, sir, we have the three unknowns for the planar structure, so we need three equations. Okay, sir, we need three equations to solve a planar structure. So we need three equations, three equations, okay, three equations to solve a structure, okay, to solve a, to analyze or to solve, okay, solve or analyze, solve or analyze, okay, analyze and structure, okay, planar structure, absolutely correct. Okay, so if there are unknowns more than four, okay, if there are unknowns more than four, the structure cannot be analyzed. Okay, with the help of these three equations. Sir, we need additional equations then. Okay, that is indeterminate structure. We need additional equations. Okay, for that case, we need additional equations. Okay, so for this case, we are putting the internal hinge. If we are putting internal hinge in the beam, if the internal hinge is present in beam, if internal hinge, if internal hinge is present in beam, the internal hinge is present in beam. So what will happen? Present in beam. What will happen? What will happen? Okay, sir, there will be one additional equation. It will give one more additional equation. Okay, it will give, it will give one additional equation. One additional equation. Absolutely correct. Okay, it will give one additional equation. It will provide us one additional equation. Okay. Now, if the unknowns are four, we have the internal hinge also present. The unknowns will be what? The number of equations will be now four, and we can analyze the structure. Okay. This is the internal hinge. Okay, this is internal hinge. This is internal hinge. So this is the analysis of beams part. So in case of analysis, we are finding the force in x direction. We are finding the force in y direction. We are finding the moments. Okay, there may be more than four, more than three, more than five. Okay, number of unknowns on an in the structure. Okay, we need to solve the structure. Okay, the available equations are three. The available equations are three for the structure. Okay, available equations are three, and the number of unknowns are more. That structure is indeterminate structure. Will be discussed. That is in indeterminate structure. Okay. Now, if I have the additional internal hinge present in the structure, sir, what will happen? If this additional internal hinge is present in the structure, there will be the one additional equation. That is, we have now the three equations present. Okay. We have now three equations present. Okay, absolutely correct. Now, this is the analysis of the beams. What is static indeterminacy in the beam? What is static indeterminacy in the beam? Okay, okay. Sir, we have the three number of equations available. That is summation fx. Forces in x direction must be equal. Forces in y direction must be equal. Moment around the z must be zero. Okay, we have the three equations available. But there can be more than three unknowns in the structure. In that case, the structure becomes indeterminate. Okay. So I'll do number of reactions could not be computed using equilibrium equations. Okay. Number of I'll write down number of reactions. Okay, which could not be computed, which could not be computed, which could not be computed. Okay, using equilibrium equations. Using equilibrium equations. Using equilibrium equations. So I'll show an example. We have the simply supported beam. Okay, we have the one hinge here. We have the another hinge here. Okay, what are the number of unknowns? What are the number of unknowns? Anyone, what are the number of unknowns? Sir, here it is the vertical reaction here. Okay, vertical reaction. Let's suppose this is A end, this is B end. Here is the vertical reaction VA, and here is the horizontal reaction HA. There is the horizontal reaction HA. Absolutely correct. Okay, and here vertical reaction VB and horizontal reaction HB. Okay, HB. So the number of unknowns are four. Unknowns are here four. Unknowns are four. Absolutely correct. Okay. But sir, but available equations are only three. Available equations are these: summation fx, summation fy, summation mz. Only three. Okay. So available equations are three. So I'll write down available equations. Available equations are three. Okay. So this is called indeterminate structure. This is called indeterminate structure. Okay. This is called indeterminate structure. This is discussed detail. This will be discussed in detail in the structure analysis. Okay. So this degree of static indeterminacy will be now. Okay, unknown is available 4 minus minus available equation is 3. That will be 1. Okay, that will be 1. Absolutely correct. So the degree of static indeterminacy is here now 1. So we have another beam, cantilever beam. We have the cantilever beam. Okay, we have the cantilever beam. In case of the cantilever beam, absolutely correct, sir. Sir, the number of unknowns here are unknowns here are sir only three, and the available equations are what? Available equations are what? Sir, they are also three. Sir, the degree of static indeterminacy. Okay, degree of static indeterminacy will be now unknowns available three minus, yeah, available equation is three. That will be zero. That's the degree of static indeterminacy is zero. That means this structure can be analyzed. Okay, using equilibrium equations. That is using summation fx, summation fy, and summation of moment around z. Okay, absolutely correct. Absolutely correct. So we have the another fixed beam. Let us suppose we have the fixed beam here. We have another fixed beam here. In case of the fixed beam, so here is the vertical reaction. Here is the horizontal reaction. Here is the moment also. Here is the moment also. Okay. Here is the moment also. Okay. And another here. On the support, we have the vertical reaction, we have the horizontal reaction, we have the moment also. We have the moment also. Okay. Sir, the unknowns are here now. Unknowns are here now. How much unknowns? Anyone, how much unknowns? Sir, unknowns are six. And the equilibrium equations, that is available equations, only are what? Only three. That means the structure is indeterminate structure. Cannot be analyzed by using equilibrium equations. Rather, we use compatibility equations will be discussed in the structural analysis. Okay, will be discussed in the structural analysis. Anyone in the chat section, are you getting my point? Are you getting my point? Are you getting my point? Anyone? Anyone? This is the static indeterminacy in the beam. Okay, this is the static indeterminacy in the beam. Okay, now we have the types of loading. We have the types of loading for you. We have the types of loading. So what are the types of loading? The first type of load is the point load. First type of load is the point load. Anyone, what is point load? What is point load? What is point load? Anyone in the chat section? Mark down the point load. Sir, point load is nothing. It is a concentrated load. Okay. It is placed at one point. It is fixed at one point. Sir, this is point load. This is point load. Okay, I will show the point load also. We have the point load, or simply we can say it is a concentrated load. It is the concentrated load. It is the concentrated load. Absolutely correct, sir. Concentrated load. Another type of load is uniformly distributed load. Uniformly distributed load. Sir, this point load is written in Newton. This can be written in kilonewton. Okay, Newton, kilonewton. Absolutely correct. We have the uniformly distributed load. Second type of load, uniformly distributed load. We have uniformly distributed load. We have uniformly distributed load. So what is this uniformly distributed load? Okay, as the name suggested, uniformly distributed. Sir, it is distributed uniformly on the structure. Okay, I'll show you. Okay, I'll show you. So this is given in Newton per meter, or this is given in kilonewton per meter. Okay, whatever. Okay, load upon length. It is load upon length. I'll show you. Don't worry. The last is the uniformly varying load, and the last is the uniformly varying load. How this uniformly varying load looks like? Uniformly uniformly varying load. Wait a second. Uniformly varying load. Absolutely correct. Okay, okay. Uniformly varying load. So let's make a beam here. This is the beam. This is the beam. Now I am making the loading here. This is the beam. This is the beam. These are the simply supported beams. Okay, okay. Sir, by the yellow color, I am representing the concentrated load. This is the concentrated load at the one point. Okay, this is the concentrated load. Okay, at the concentrated, this is concentrated load. Absolutely correct. Okay, load P. Absolutely correct. Now, what is UDL? What is UDL? Uniformly distributed load. Sir, this is the uniformly distributed load. By the white color, this is the uniformly distributed load. Okay, it is uniformly distributed. It is uniformly distributed on this section. This is the UDL. This is the UDL on this structure. Okay, absolutely correct, sir. Now, sir, what is uniformly varying load? What is uniformly varying load? What is uniformly varying load? Anyone? What is uniformly varying load? Sir, this load varies uniformly on the structure. Sir, this is the uniformly varying load. Okay. Sir, on this section, wait a second, wait a second, wait a second. Sir, on this section, the load is zero. On this section, the load is zero. It is uniformly increasing, linearly increasing, and the load is maximum here. Okay, sir, this is second type of loading, and this is third type of loading. Okay, sir, this is all about the loading. Anyone, this is all about the loading. It's all about the loading. Okay, this is all about the loading. Everyone in the chat section, please raise your hands. Raise your hands. Is everything okay? Is everything okay? Now I'm discussing the concentrated, okay, concentrated moments. I'm discussing the concentrated moments. Now, what is concentrated moments? Concentrated moments. I'm discussing the concentrated moments. Okay. So the moment at one place is the concentrated moment. Is the concentrated moment. Look at the beam. So this is the beam. This is the beam. This is the beam. Okay. This is beam. Okay. This is beam. We are applying a moment M. We are applying the moment M like the concentrated load. Sir, this is what? This is the concentrated moment. Or I'll show you another. I'll show you another case of this concentrated load or this, sorry, concentrated moment. Okay. Sir, this is the beam. On this beam, we are placing the, okay, in the vertical direction, we are placing the beam. Okay. On this beam, on one side, we are having the load. We are having the load. On the other side, sir, we are having the load. We are having the load. Okay, absolutely correct. Okay. So this distance is L by 2 and this distance is L by 2. Okay, L by 2. And I am applying the load P here. I am applying the load P here. There is a moment generation. There is a moment generation. Okay. That is a moment generation of PL here. Sir, this moment is concentrated moment. Okay. This moment is concentrated moment. Now, this is concentrated moment here. This is concentrated moment. Okay, concentrated moment. Absolutely correct, sir. This is concentrated movement here. Now I am making the uniformly distributed movement. So how this uniformly distributed movement looks like? Okay, how this looks like? This is the beam, sir. This is beam. Now, like the same, sir, like the same. We have applied here the uniformly distributed load. Same we can apply the, okay, uniformly varying load. Uniformly distributed movement. Sir, this is the uniformly distributed movement. This is the uniformly distributed moment. Okay. This is the uniformly distributed moment. Okay. This is moment M. Sir, the unit is kilonewton meter per meter. Okay, per meter. This is the uniformly distributed moment. Okay. This is uniformly distributed moment. Absolutely correct, sir. This is the this is the uniformly distributed moment. Okay. Absolutely correct, sir. Absolutely correct. Okay. So these are the concentrated movements. What we have discussed in the class, quickly, what we have discussed in the class. So we have discussed first, okay, we have discussed first the type of support. We have discussed the type of support. We have so we have discussed the type of loading. Okay, we have discussed the type of loading. We have discussed type of loading. Okay, we have discussed concentrated movements. Okay, so this was today's class. So the part two of this class will be discussed. Okay, the part two of this class will be discussed in next class. Okay, the part two of this class will be discussed in next class. Don't worry. Okay, okay. So the part two of this class will be discussed. Will be discussed in the next class. Okay. So again, what we have for you. So we are having the aim badge for you. We are having the aim badge for you. Okay, in our application, resultant, we have the aim badge for you. Okay, what is happening? So we have, wait a second. So what we have for you, for all the we have the aim badge. Okay, for RRB JE CBT2 classes are going on. Okay, classes are going on. So you will get 400 hours of live classes. You will get PYQs and quiz sessions. You will get test series. You will get doubt solving sessions. Okay, okay, and all you have to do, download the Resultant civil app. Okay, and if you need the information, you can contact these numbers. These are provided for the civil support. Okay, you can contact Abhinav sir. Okay, so what are the facilities available on our application? On our application, you can get class handouts. Okay, daily class handouts. You can get class polls. Okay, we are discussing the question is there for RRB JE CBT2. We are discussing the daily practice questions. Okay, we are discussing there is the educator support. You can call anytime. You can call anytime. Okay, and we'll provide you the best service. And we have the live classes for you. We have the live class schedules for you. Okay, we have the study material for you in the PDF format. In the PDF format, and we have unlimited courses there for the GATE and ESC also. We have the top educators on our platform like Abhinav sir, Richa ma'am. Okay, okay, the old Byju's faculty is there. Okay, so CBT one book is available for RRBJ aspirants. Okay, CBT one is available for RRBJ aspirants. Okay, everyone. Okay, so aim batch for CBT2 is coming. Okay, CBT2 is coming. CBT2 is coming. Okay, thank you so much for joining the class. Thank you, everyone. Thank you so much. Thank you for joining the class. Thank you. Take care, everyone. Thank you.